Welcome to Calculus 3. In this short video, I want to give you a quick idea about what this course is about and how it's different than previous calculus courses that you've taken. In those previous courses that you've taken, you've learned a lot of different topics related to calculus, but you could boil it down to just a couple simple ideas that you looked at in a lot of different scenarios and applications. So really what Calculus 1 and Calculus 2 were about, we're looking at differentiation and integration. Of functions of one variable. So a lot of times these last three words, the functions of one variable, a lot of times that gets kind of swept under the rug because in algebra and pre-calculus, almost every function that you discuss has only one variable. And that's what happens in calculus 1 and 2. So for example, you might take a function like f of x equals x squared plus e to the x sine of x. Right, which is a function of one variable, x. And you can differentiate it, you can integrate it, you can take limits, and do anything else that you did in Calculus 1. In this course, in Calculus 3, what we're going to really focus on is not sort of continuing to build more calculus or more techniques outside of differentiation and integration. What we're going to do is we're going to extend these ideas. So the ideas of differentiation and integration to functions with more than one variable. So in this course, we're going to be looking at maybe things like this. So maybe f of x, y. We have two variables, x and y. So x squared plus e to the x sine of x, y. Right, some kind of function like this. And the functions work much the same way. You know, we have pick any real numbers x and y and evaluate this function at those two numbers. Replace x with your first number, y with your second, and you'll get an output of a single real number. And so this will be kind of a typical type of function that we look at eventually. But a lot of this course is going to be how do we extend the ideas that we already know in calculus, particularly differentiation and integration. How do we take those ideas and study functions of multiple variables, such as the one at the bottom of the screen, with those techniques. And so in order to do that, we need to build up some different machinery, some different tools to use to study these functions. And so the first couple sections of this course that we do, this is going to be our goal, is to build up the machinery that we need to be able to understand how to extend calculus to these multivariable functions. And so we're going to start not by talking about calculus itself, but we're going to start by looking at three-dimensional coordinate system and how that works so that we can visualize these functions. We're going to look at how vectors work. You've probably seen vectors before in some context, either in, say, a physics class or a linear algebra class, but I'm going to take the approach that you've never seen vectors before and have no idea how they work. So we're going to take from a ground up approach on vectors and vector algebra. And then we're going to start seeing how vector algebra plays a role in determining equations or determining formulas for lines and planes. And so once we have all of that, then we'll be able to start looking at vector valued functions and multivariable functions. Right? So this course, the way that it's structured, it won't look like we're doing calculus right away. But what we'll be doing is getting ready to do the calculus when we get there.